Hello and welcome to another video on how to create a game like Clash of Clans. So in the previous video we learned how to set up the camera and we created the camera movement, but in this video we're gonna focus on the zoom. So this is our client and let me play the client. Now let's select the camera, and here as you can see, whenever I change the orthographic size it will zoom in and out, and we can use this to implement zoom in our game. So before we do that we need some input. Setting up input for moving was easy, but for zooming it is different. We're gonna set up two different zoom scenarios, one for mouse scroll wheel and the other one for touchscreen. So to do that, let's go to our script and input and create the proper inputs for both mouse and touchscreen. To start, I'm gonna just add the mouse scroll wheel, and it's going to be a float value. We're gonna choose axis and we're gonna set up mouse, and here at the scroll section we're gonna choose Y. We also need to know the position of mouse when we zoom in and out. So we create another input action and we're gonna name it mouse position. And this is going to be a vector2 value, and the binding would be mouse and position. So let me collapse this two. Now we need to create the actions for zooming with our touch screen. So let's create a new action. I'm gonna name it touch zoom. The action type is gonna be button, and we need to make sure whenever player puts one finger on a screen and after that it places another finger on the screen, then that's when the zooming happens. To do that we need to add a binding with one modifier. So let me delete this default binding first. Now we have this binding which takes two parameters. So the first parameter, which is the modifier, is going to be touch screen, and it's going to be touch zero contact. So whenever touch zero gonna make contact, and let's go to zoom, and in the interactions make it press. So press only. So when touch number 0 gets pressed, and then after that touch number 1 gets pressed as well. So let's go to touch number 1 and choose touch contact. In this case we are zooming. So we also need the position of both fingers, so we need to add them as well. Let me collapse this and create two actions. It's gonna be touch position 0, and it's going to be a value of vector2, and of course it's gonna be touch screen touch 0 position, and we're gonna create another action and name it touch position 1. This is also going to be a value of vector2, and we're gonna bind it to touch number 1 position. So basically that's all the input we need for now. Let me save this, let me close this, and let's go to our camera controller script. So first of all, let's implement zooming with mouse scroll. We're going to go to update, and here right before moving I'm gonna check to see if our screen supports touch. So if input.touch supported equals to false, which means our screen does not support touch, and we assume we're in the editor and we are using mouse scroll. So before we get into zooming, let's create a bunch of default values. I'm going to add a few variables. The first one is going to be zoom speed, and we also need a boolean for zooming. And let's also add a value for zoom. So the first thing we do in our initialize, we're also going to pass a zoom value. And here we're going to assign our zoom. Also we're going to set the camera orthographic size to this zoom value. And let's set the zooming to false as well. Also let me copy this. We need to constantly set the camera orthographic size to zoom here in our update function. But it would be better to do something like this position here. Let me copy this. And instead of doing that, I'm gonna say check to see if the camera orthographic size equals to zoom value. Okay, so if it's not equals to zoom value, then go ahead and set camera dot orthographic size, and we're going to say mathf dot lerp, and we're going to lerp our camera orthographic size to our zoom value. And we need a zoom smooth for this. Let's create a zoom smooth. And also let's make this zoom speed a serialized field. And let's cut this and bring it up here. We also need a minimum zoom and maximum zoom. Let's actually set them up here. And we can pass the value here on the initialize. And let's assign their value. Now let's go to our start function. Set the default zoom to 5, minimum zoom to, let's say, 3 for now, and 10 for now for maximum. Of course, we're going to calculate the precise numbers, but for now, let's just leave it as that. Now, let's go back to our update function, and first we check to see if our touch supported equals to false or not. If it's false, then we're going to zoom using our mouse. So we need a float value. Now we can check to see if our scroll value is greater than 0 or less than 0. So whenever mouse scroll is greater than 0, we're just gonna multiply a speed value, let's say 1. We are not going to use the zoom speed that we created up here because that's for our touch. Basically with mouse, we really don't care. It's just something to look at in the editor. So zooming with touch is our main goal. And this mouse zoom is just a tool for our editing. So let's actually change this number of zoom to, let's say, 3 and see how this looks. As you can see, I'm moving my scroll wheel and I can zoom in and zoom out. So that's it for our mouse for now. Now let's focus on our touch zoom. So for zooming, we're gonna do exactly what we did with moving. We're gonna start creating the relative events. Let me expand this. Let's actually copy this to move started and move cancelled values and paste them here. And instead of move started and move cancelled, we're just gonna change their name to zoom started and zoom cancelled. And of course, this is going to be zooming equals to true and zooming equals to false. Now we need to add the listeners here on enable, and let me just copy these values. And instead of move, we're gonna say touch zoom. And instead of move started, we're gonna say zoom started and zoom cancelled. It would be also better if we remove the listeners in our onDisable. Let me copy all of those values and just say minus equals to. And here in the update, before we do the moving, first we check if we are zooming or not. And else if we're not zooming, then we're gonna do the moving. We can't do them together. Okay, so if the zooming is false, then we're going to check if we are allowed to move or not. So before we start writing the necessary codes for zooming, let me create a couple of helper functions. So the first one is going to be a Vector3 method. So the first function is going to get a vector2 position, which is a position of our screen, and change it to a world position. So we need two values for our height and width. So you might know this, but camera.orthographic size is half of the height, and we can calculate width of the screen by multiplying the height by camera aspect ratio. So let me open the paint. So basically, if this is our screen, whenever we give this function a point of this screen, it will be a position relative to this anchor. So for example, if your width is 90/20 and this is 1080, the position of this point is gonna be a value which is gonna have an x and y, and the x is going to be between 0 and this number, and y is going to be between 0 and this number. Okay, so this is a point on your screen, and you want to turn this to a world position. Of course, the camera has a function for this, but since we are setting the camera near plane to 0, that might also return 0. So it would be better to calculate this point ourselves. So we need this point in the world as well. So as I mentioned before, camera orthographic size is going to be half of the height, which is this value. So here we're gonna say camera orthographic size multiplied by 2 is going to be the full height in the world position. And we're gonna multiply this height by camera aspect ratio to calculate the width as well. So now we have height and width in the world position. Now we need to calculate this point here. So as we know, camera transform dot position is this point, the center of the camera. So we need to move into the left half of the screen wide and move down half of the screen height to reach this point. So let's actually do that and calculate the position of this point. So we're gonna reduce two values from our camera transform position. And make sure you always normalize the directions. So that's it. That's how we are going to calculate the anchor point of our camera in the world. So now all we have to do to convert the screen position to the world position is to get the percentage of that screen position. So to do that, we're gonna divide the screen position into screen width and height, and it will give us a percentage. Then we are going to multiply that percentage into the world height and width, and we're gonna move on right direction and up direction from this point, and it will give us the relative point in the world. So let's do that. So we're gonna move the anchor point in two directions, the right direction and up direction. Let's do the up direction first. So we're gonna say move the camera in the up position from our anchor. We're gonna divide this position, which is our screen position .y, by screen height. This will give us a number between 0 and 1, and we're gonna multiply that by h, which is our height in the world, and it will give us a distance in the world position, and we're gonna move up that amount of distance. And we're gonna do the same thing for our right. Let me just copy this and paste it here, and instead of h I'm gonna say w, and this is going to be width, and this is going to be x, and this one is going to be right. So we're gonna return that value, and simply we're gonna converting a screen point to the world point. Now we need to create another function. This one also going to return a vector3. Let me just copy this. And instead of camera screen position to world position, it's going to be to plane position. Plane is going to be our ground. So let me open the paint one more time. Let's delete this. So let's say we're looking at our camera from the side, left side or right side, doesn't matter. This is our camera, okay? And this is our ground. This is the camera looking at our ground. We're gonna say this is a plane, okay? So this is how it's looking. And let me extend this. This is our camera, and it's looking at the ground. So basically this area of the ground is visible to us. So we want when the player clicks on a point of the screen, we get the relative point on the plane. So let's say player clicks on this position, and this position until the plane is going to give us a height. We're gonna call that height. So what we need here is this distance. So if we have this distance, let me actually draw it with color red. We need this distance, and let's call it x. So if we have x, then we can get that position and multiply the camera forward by that distance, and it's gonna give us that position on the plane. Okay, so how we can get x? We already know that we have this angle. It's 45. If you remember, we set it up in our script, and it's our camera angle. We have the angle. It is 45. Let's just say it's A. So we know that sinus A equals to h divided by x. And this is going to tell us that x equals to h divided by sinus A. So first we're gonna calculate h. Let's do that. Let's go to our function. It takes a screen position. Okay, so we're gonna use this function to get the world position of this point. So to do that, we're just gonna say vector3 equals to camera to world position, and we're gonna give it this screen position that has been passed to us. We also know that our camera root is on this line, okay? So the y-axis of our camera root position minus this point position, and the difference of these two green positions on y-axis is going to give us h. So this point we already got, it is point, so we're gonna say float h equals to point dot y minus camera root dot position dot y. And now we have h. We also have a, which is the angle. We can simply calculate x. So let's do that. Also, we need to multiply the angle by mathf dot degree to radian. Now we can simply multiply the camera forward by x, and it's going to give us this position on the plane. So let's return point position multiplied by camera forward, and we're gonna normalize it, and we're gonna multiply it by x, and this is going to be a plus. So now let's go and create a bunch of variables for our zoom. The first ones are going to be zoom positions that we're gonna store, and it's going to be a vector2, and let's name it zoom position on a screen. And the second one is going to be zoom target in the world, and it's gonna be a vector3. Now we need two floats. One of them is going to be zoom base value, and the other one is going to be zoom base distance. So now we have all of them. Let's go to zoom started and assign these values. So first we're gonna get the touch positions. And the second one is going to be touch number 1. Okay, and this is going to be touch number 1, and we need to get the center of these two touches. So let's just say touch center, and we can easily get the center of these two touches by using vector2.lerp. It's going to lerp from touch 0 to touch 1 by amount of 0.5. It's gonna travel half the distance between these two positions, and it's going to give us the center position of these two positions. So this touch center is actually going to be our zoom position on a screen. So the zoom position on the screen is going to be this value, and using this value we can simply get the zoom position in the world as well. So it is equals to a screen position to plane position, and it's going to pass zoom position on a screen. We're gonna pass that and get that position as well. So the base value of our zoom is our current zoom, of course. That is our current zoom, and we need to get the distance between the two fingers. So if this distance changes, we're gonna zoom based on that. So in order to get the distance, we're gonna convert them to percentage. So we're gonna say touch0.x, we're gonna divide this by screen width, and we're gonna do the same thing for touch 1. Now we're gonna do our y-axis, and we're gonna divide it by screen.height. Now we can simply get the distance between these two touches. So our zoom base distance equals to vector2.distance, and the distance is going to be between touch 0 and touch 1. So we're done here. Let's actually copy this. We need some of them in our zooming. Let's go to our zooming place. Okay, here it is. I'm gonna paste this. We don't need these 3 lines, but the other lines we need. So basically we're getting the 2 touch points. Again, we're gonna convert them to a screen percentage, and instead of doing this, I just gonna say float dot current distance, and we're gonna create a float called delta distance, and it's going to be current distance minus zoom base distance. Now we can simply just say zoom equals to our zoom base value minus our delta distance multiplied by our zoom speed. And that's for zooming. Let's also take care of the positioning. So in order to implement a pinch zoom, we need to move the camera based on the center position of our finger. So to do that, we need to create a vector3 called zoom center, and it's going to be the exact value we calculated here. And we used the zoom position on a screen which we saved on our move started, which means the position between our fingers on the screen must align with the world position for when our zooming initialized. So let's just copy this. I'm just gonna bring it here, and I'm gonna say zoom center is going to be that, and this is the position we initially saved on our zoom start. We're gonna just move our camera root, gonna say plus equals to, and we're gonna say the initial zoom position that we saved here on the zoom started. This is the position we saved here. We're gonna say that position minus the position we just calculated, which is our zoom center. And this should do our pinch zoom for us. Of course, we need to get a build to see how this works on a mobile device. I'm gonna do that, and if there is a bug, I'm gonna mention it in the next video and fix it. But for now, this is it, and this should work. So let's create another function here, and I'm gonna call it just bounds. And I'm gonna call this adjust bounds just before I set the values of my camera in the update function. So this is it, adjust bounds, and this is our orthographic size that is going to be set. The same thing for the camera position. So before we set the position and zoom, we call adjust bounds to make sure the values do not exceed their limits. Okay, I'm gonna do that in the next video. This is enough for this one. And if there is any problem, I'll fix it in the next video. So thank you for watching.